that we have presentation and discussion here in the public of the meeting, and then in the very end, when the discussion is over, we ask everybody to leave who's not a professor at the ET or a co-supervisor, and then we'll come up with a verdict. To tell you, you have 20 to 20 minutes, maximum, absolute maximum is 25, which kind of will cut you off. So please take that into time, and then we'll start with questions. Okay, thank you.
All right,
it was yours.
All right, thank you very much, Professor Schwabe. So, as already mentioned, the topic of my PhD is an intent-based blockchain agnostic interaction environment. And the agenda for this presentation is going to be a brief motivation on the topic. I'm going to present the research challenge and the questions as well that we set up for this PhD, the design and evaluation of the solutions and what is the concept behind them, and conclusions and the contributions as well. So in 2009, we saw the first, let's say, blockchain being released, the first platform being released, and that was Bitcoin. However, since then, we saw several other blockchains being proposed and developed. One of the most popular ones, Ethereum, was released in 2013, and since then, others follow. One problem with that is that they didn't follow any standards in terms of development and didn't follow any technical guidelines, let's say. And these technical differences, they lead to a very complex selection process if I want to select a blockchain for my use case, which is the best one, right? Further, this is even a little bit more complicated when we talk about stakeholder requirements and we want to map them to a blockchain. So for example, if a producer in a supply chain wants to use a very popular blockchain or a very stable blockchain, they will select, for example, Bitcoin. And other stakeholders might select different blockchains. For example, a retailer might select Ethereum because of its smart contract functionalities, for example. Right? Further, this leads to a problem with interoperability between those blockchains, because as soon one of those stakeholders select a blockchain, how we're going to exchange data between those different systems, right? With that, we have the lack of standards with regards to this interoperability of blockchains. We don't have an inter-blockchain communication, and the complex interaction also arises from this lack of standards in blockchains, which also leads to the creation of blockchain project islands. So for example, Bitcoin is only going to produce code for its code base, not for Ethereum. Data silos, as soon as one stakeholder select one blockchain, it's not going to migrate to a different one. And also the ossification of blockchain-enabled systems, because as soon as one of those stakeholders select, they're not going to change to a different blockchain because of the effort already spent. This led to the identification of three main challenges. The first one is a non-trivial trade-off when mapping stakeholders' requirements to a blockchain implementation, leading to the first research question: how can non-technical stakeholders define intents, highly abstract policies, which are translated to low-level, mainly technical blockchain selection actions on how to select a blockchain? The second challenge was the necessity of understanding technical details to select the most appropriate blockchain. So as you saw, there is different technical details, and if I want to select one, I need to understand those. Leading to the second research question, how to select the best suitable blockchain in terms of number of fulfilled requirements, for example, costs, based on those intents defined by the stakeholders. And the third and last challenge is the high complexity of blockchain interaction at the moment, and the lack of approaches that address such complexity, because we are just introducing more blockchains, but not dealing with the complexity that they increase and they produce, right? Leading to this, the third research question: is it possible to provide a blockchain agnostic solution capable of abstracting those technical details from those different blockchain implementations? So providing a common ground for a system or a user to use and to interact with several blockchains. And all of those research questions, they are composed or compromised by the fourth one, which are the architectural components and actors necessary to build such a system that we can go from an intent to a blockchain transaction at the lowest level. This research question 4 was firstly answered with the proposal in my thesis of a blockchain intent continuum refinement following the policy continuum, which is a mature refinement flow of policies to low-level actions in computer networks. So in this first part of the continuum, we have the service level agreements, for example, mapped as intents. And these are defined as the stakeholders' requirements. Those are very abstract, let's say, abstract requirements for that case. Then they can be refined to event condition action policies, which are the blockchain selection policies, which are the requirements that are going to be used to select a blockchain using that. Those are then refined to a more technical aspect, which is a blockchain independent or agnostic in this case transaction, or a transaction to the API, which basically is an interoperability API call. So it's just a call in an API. Those are then needs to be refined even further, because now we are talking to a specific blockchain implementation. So we need to create, sign, and also forward that transaction to a specific blockchain, leading to the last level of the continuum, which is the instance view. So the blockchain node remote procedure call. So we cannot refine that even further, because that's the last step of the continuum. And this, we already have a very technical transaction, which is a raw hexadecimal, a transaction and sign as well. This intent here is basically being implemented in a 3-layered architecture that we also proposed in the thesis, composed of 3 different layers. The first layer is the management layer, composed of the blockchain blockchain-driven intent refinement, which performs all the refinement from a high-level intent defined by non-technical users. The decision layer, which is composed by the policy-based blockchain selection solution, which is going to select the blockchain based on those policies refined from the intent. And the enforcement layer, which is composed by the modular blockchain interoperability API, which is going to interact and send data to those specific blockchains. Each one of those solutions, they were proposed to address the research questions, and the research question 4, which is the architecture. It's basically answered by that architecture composed of those 3 solutions, and also papers and publications. They prove and support all of the scientific and technical content of that solution. So for the first solution, we developed a controlled natural language. We defined a grammar for that in the extended backwards null form, which we allow the intent to be composed as sentences. So for example, for clients, select the fastest and popular blockchain. This intent is now parsed using a state machine, where each state represents a token in the intent. So it can be considered as a word, for example, and we can provide straightforward validation of that. Lookup tables are used to refine the intent, or to basically select a policy that matches to that intent. And this is all implemented within the intent refinement toolkit, where requirements are expressed as intents in English, and it refines those high-level abstract requirements. The second part of that architecture is the policy-based blockchain selection, where we use policy-based management with policies that contain the requirement to select a blockchain. We apply filters to basically limit the set of the blockchains that we have, where we consider static parameters, for example, the type, the data supported, and the TPS, transactions per second, or dynamic, that change very often during the blockchain implementation, which is the popularity and the currency price with this volatility, right? We designed 2 selection algorithms, one that prioritizes economy and another one that prioritizes performance to select the blockchain. The switching of policies is based on the time frame. So one policy is going to be active during the day. or costs as well. And the policy conflict, so one policy can only be active within that time frame. We cannot have two policies active in the same time. And all of that was implemented in Plebels, which is a policy-based selection framework. The modular blockchain interoperability is a solution that interacts with a blockchain, so sends data to a blockchain. We provide blockchain interoperability using a notary scheme, basically a gateway to manage transactions. We allow a transparent blockchain interaction, where the details from all of that interaction from blockchains, they are hidden from the user. The user doesn't need to maintain any blockchain clients, doesn't need to have any knowledge of the specific blockchain, for example, Ethereum or Bitcoin or Stellar. We allow the storage of arbitrary data, so a character string. We are not restricting the user to a specific type of data format. And we allow also data retrieval to retrieve the stored and migration of the data, so a copy of the data. We also have a standardized interaction with the API based on a JSON, which is also a character string. And this was all implemented within Bifrost, this modular blockchain interoperability API. So as soon as those solutions were designed, implemented, they were also evaluated in two different dimensions, quantitative and qualitative. IRTK was evaluated in terms of the refinement execution and the intuitiveness of the language. Plebels was evaluated within the performance time to select a blockchain and different scenarios. And Bifrost was evaluated in terms of the transaction creation time and the security assessment of its real-world deployment here at the university. For the intent refinement execution, we performed 1,000 refinement interactions using simple, intermediate, and complex intents. And what we found was, at average of 5 milliseconds for the most complex intents, we're able to refine them and to have a policy being created. For the language intuitiveness, we performed a questionnaire with 19 participants, composed of technical persons and non-technical. They didn't have knowledge of the language, and we asked if they are which representation is more intuitive, either the CNL, so the intent-based one, the one on top, or a pseudocode representation with a more JSON-like style. What we found was that both technical and non-technical individuals, they benefit from the abstraction layer, so it can be considered an intuitive language even for technical and non-technical users as well. For the blockchain selection process, we analyzed we defined 6 policies for one user, where those policies contain different cost thresholds and also requirements to select a blockchain. What we found was that the selection algorithm takes 0.2 to 0.5% of the total execution time, going from selecting a policy to updating the costs. So all of the, let's say, life cycle of selecting a policy. And also that it was impacted, this time was impacted by the blockchain pool size. So as soon as we have a larger blockchain set, for example, it will take more time. So that's why we use filters to reduce that time. For Bifrost, for the transaction creation time, we implemented 8 blockchain adapters from Bitcoin to Stellar, EOS, IOTA, and Hyperledger, so the most popular blockchains at the time. And we've basically analyzed the time that it takes, the overheads to create a transaction. So create, sign, and send. We found that the remote nodes, so if we don't have a local node inside our infrastructure, it will impact more in the time to create because we have network latency. And we also found a similar performance between blockchains and a database. So for example, multi-chain and Postgres, they had a very similar performance in that case. We also performed a security assessment on a real world deployment of Bifrost, where we conducted a risk analysis and we identified a risk matrix for that. We have here where these cells here represent the amount of risks found and also their likelihood and the impact, going from very low to very high. So most of the risks, they are within the moderate range. So we can see here in blue. where we have, for example, 8 risks, 2 risks, 4 risks. High risks, they really need to be reduced if we are going to basically deploy Bifrost in a production setting. So we need to consider this to reduce. And if we have risks that are moderate, we can accept them or reduce if they are, let's say, as low as reasonably practicable. So if the cost to reduce that time, it's that risk, sorry, is valuable in that sense. And just an example of high risk. So what would be a high risk for Bifrost? If the private keys of the blockchains, they are compromised, then we know that we have basically funds being stolen, and that could be a very, let's say, critical risk for Bifrost in a production setting in that sense. So in terms of the thesis contributions, the first research question was answered with the employment of intents to define the requirements and also to reduce the technical blockchain knowledge. Okay. Let me try to unmute. Okay, so everybody's no. Oh, it's the first. Okay. Nice. Okay, sorry about that. So the first research question leads to the first contribution, which is employment of intents. So the CNL and also the refinement toolkit. So how we refine those intents. The second research question led to the second contribution of the thesis, which is the employment of policy-based blockchain management. So a very consolidated management concept in the policy-based selection, and the development through algorithms, the performance and cost-aware algorithms. Research question 3 led to the third contribution, which is the API, or the transparent interaction with multiple blockchains using a notary scheme to provide the blockchain interoperability in that case, and also this simplified interaction and transparent as well. The fourth research question, sorry, led to the fourth contribution of the thesis, which is the standardized blockchain intent continuum. So going from a very abstract intent, very abstract requirement from a user, to a very low level blockchain transaction being sent to a specific blockchain. Also with the user interaction and the refinement strategy that follows this intent, and also the contribution, I could mention the 3-layer architecture, which could be applied to not only blockchain selection, but to other selection approaches or use cases. For example, selecting a network function from a set of network functions, for example. So to conclude, the stakeholders' requirements now they are easily translated to a blockchain, because now we have users being able to write intents, to express their intents in English, so in a subset of English, but in a very straightforward way. The cost constraints and SLAs, service of agreements, are met because we have policies that guide the selection and also that basically guide the execution of the environment. So those are can be met. The technical complexity of blockchain interaction is also reduced because now we have Bifrost. Now we have an interoperability solution that is able to interact with several blockchains without the user knowing specific details of that. In terms of future work, we can consider the intent feedback and also the monitoring, because at the moment we are not considering if the intent is being fulfilled. So is the blockchain that was selected is going to continue until, let's say, the overall execution of the environment? Is it going to still be that one? For example, a fast blockchain might not be a fast blockchain because of some changes in their code. Also, research on using machine learning to select a blockchain to provide a more flexible selection in that case, and also allow the API, so Bifrost, to interact with smart contracts, because at the moment we are just interacting with sending a transaction, we are not interacting with smart contracts in Ethereum, for example. So that could be a future work to be researched. So we had, during this 4.5 years, so 4 years and a half, several publications that directly related to the thesis, and also several other contributions with the group, and also with outside as well. So that was it for now. Thank you very much for your attention, and if you have any questions, I'm happy to take them later.
Thank you very much.
Thank you.
Great time, perfect.
Good, thanks.
Thanks a lot. I think, according to addition, the co-supervisor first starts with the questions, then the supervisor, and then you take ping pong.
Thank you very much. So I will start. So thank you very much
Thanks.
for the great presentation, and we appreciate it. It was also a pleasure to read the manuscript. Before starting the question, I would like to mention that the manuscript really constitutes a major and original contribution to the field of network and service management, and more general to the field of networking and blockchain. The manuscript is very well written. It reflects the highest quality and rigor of scientific and technical contribution. So it's a good contribution for that. I will now go through the different chapters for asking questions. So the first chapter is an introductory chapter where you introduce in particular the context of blockchain and their interoperability.
Yep.
In your work, you proposed a solution where you exploit intent-based management for selecting blockchains.
Yes.
I was wondering if blockchain technologies could also support your intent-based management solution, and if yes, at which level in the intent refinement continuum?
Good points. I think that's a very good question. I didn't thought this, let's say, on the going from any blockchain to an intent, for example. But I think blockchain could be used to support intent-based management, where you could provide, let's say, an immutable ledger for the decisions that you take. And then, for example, why did that blockchain was selected, right? I could store that decision in a blockchain and then provide to the user that was the reason why, right? So in terms of immutable. In terms of intent-based networking, for example, we could also apply that using the blockchain as this immutable database, but not directly contributing to the intent field, but to providing this, let's say, trustful log in that sense. Using more as a database, not as like a support for intent.
So in this chapter, you first introduce the different contributions. It's a more general question. Which research question was for you the most difficult to address, and why?
Most difficult one. Good point. So if I would go back to
because there are many contributions and interesting research questions.
Exactly. So if I would think about the research question that was the most difficult in terms of the, let's say, these three here, I would say all of them they are quite complex. But I would say that the second one, which is how to select and how to provide these, let's say, algorithms or ways to select a blockchain, that was one of the most tricky ones, and how to employ policies in that case. Because the definition of intents, it's straightforward in the sense of I can provide a level of abstraction, but in order to, how can I quantify, for example, non-quantifiable parameters, for example, popularity, right? Popularity are very subject parameters. For example, something might be popular for me, but for some of you might not be popular, right? So how can I quantify that? So this quantification also is very difficult here in this part. In the first one, how to define, that's a little bit straightforward because we have CNLs, we have other solutions that can help to define that. But if I would have to select one.
And so in your solution, you use intent-based management to support the selection of blockchain, as you say. It's this part particular challenges, as you mentioned. I was wondering if there are some categories of data or of knowledge bases that could be used complementarily to the information that you have to improve the refinement of inference. That are more user specific data or blockchain or application domain specific data.
Good point. This, in terms of knowledge base, is something that it's. I mean, blockchains will have 10 years of, or 11 years, so it covers. So it's a very not that mature field. So there is no, let's say, knowledge base that we can use or taxonomy. There are some taxonomies that are proposed, but there is not like one single one that we could use. So it's a very delicate thing and a very novel at the moment, right? So it's very hard to select one knowledge base. If I would say what could be used in terms of this intent, we could try to apply artificial language or some like learning in order to learn from the user what the user is meaning by fast or what is in that sense. But there is no like taxonomy being defined.
Thanks. Thanks, Eder. I just sort of won't repeat what Rémi said with respect to the overall impression. I think that's very visible to us who did read and comment on the thesis. So, very nice piece of work. If I pose my two first questions in here, I took a look at your figure where you placed the number of chains over the years between only a dozen until 20,000 roughly today. And the time when you started thinking about that was 2019. We only had 2,000 chains, roughly. Why did you believe that the selection might become eventually a problem in the blockchain selection?
Good question as well. If I would see that graph, I have the graph in the slides in the backup slide, but it takes some time to search because it's on the hidden some animations. But I would say it's a problem because of this not steer development. So at the moment we have, I think it's 200 blockchain platforms that are different. In CoinMarketCap we have 19,000 cryptocurrencies, tokens, and blockchains as well. But in terms of platforms, there are 200, which is quite a high number if I want to, for example, select by myself. Like I would need to go to those technical details. So thinking about all of those details. So the consensus mechanism, the block time of all of those 200 blockchains, and to select one specific to my use case, I think that would be a difficult thing. If I would think about the future as well, I think it tends to grow. At least I think it's going to reach a point where we didn't reach the point of stagnation of proposal of new blockchains, I would say. I think there still might to come, and with different parameters, different technical details. And I think this list here of 2,000 more is going to just increase in that sense.
Because the title of your thesis is blockchain agnostic, or there is a term blockchain agnostic. Based on what you've motivated now, would you think that you can apply the same approach to a different set of, let's say, frameworks, identities, when you just have a chance of quantifying them with respect to such parameters?
Thanks. Yes, I think so. Yes, we could apply, because the methodology to go from, or this, let's say, the intent continuum that we have, we could apply this for other use cases as well. So we could go from an abstract requirement. For example, I want to select a programming language that is, I don't know, fast, or that is applied to this use case, that is, or better applied to this use case. And then I could go all the way to, for example, even the instance view where I really have or even in the net, this view here, I already have a programming language. Or, for example, in this case, during my master's, we applied the same concept of intents to network functions, to select a network function that would provide a set of requirements. For example, security. How can I secure a data flow between one router to the other? We could apply this as well, selecting the network function that could compose that. So yes, I think it could be applied.
Okay. You motivated your approach by looking at the supply chain application field, which was the nice argumentation with respect to the fragmented pillars, silos later on. You refer to the data part. Is there any other application field which might require blockchain interoperability besides supply chains?
Mm-hmm. Good point. I think every field that we have, or every use case that we have, users that don't trust each other but they need to, let's say, interact, we could apply this or benefit from this use case. Supply chain is one of the largest, but we could use, for example, playbills, so the policy-based selection or the intent, as a recommendation system by itself. So we don't need to rely on Bifrost for that sense. So we could just stay with this part here and select a blockchain and just do whatever it fits that use case. Or we could apply the modular blockchain interoperability, this agnostic solution, to notary schemes, for example. If I want to have my data being notarized, so stored immutable in, I don't know, Stellar, I could use the modular blockchain interoperability API to store that. So we could use those solutions in a modular way. The environment is very flexible.
So I will continue with the next chapter. So chapter 2 describes the fundamentals, serving as background to explain the thesis contribution. These fundamentals are described in a very precise and pedagogical manner, clearly highlighting the challenges and issues related to the topic. The chapter in particular introduces the relationships between software-based management and intent-based management. There is a need in some scenarios for making software-based management more distributed. Do we have the same challenges to make intent-based management more distributed? And how can we address this challenge?
Thanks. Good point. Yes, I think we do have this problem of making intent-based in a more decentralized way, or management in a more decentralized way, because with intents, we do have the notion of monitoring and reconfiguring the devices, right? So we need to have this, let's say, you have one slide here. So we do have this monitoring reconfiguration of the intent-based management, where we need to monitor and also reconfigure in a very distributed way several devices. So in a way, we still need to have this decentralization, and I think that's one of the key issues here at the moment. Having this feedback loop and also this performing this whole life cycle of the intent in that case. But still, of course, we do have the intent definition in a central solution where it's going to basically realize the intent and send the intents. But in this part, in the enforcement and in the monitoring, yes, that's one of the key issues of the distribution.
The chapter also presents and compare a set of consensus mechanisms that are used for supporting blockchains. From your analysis, which consensus mechanisms are the most resilient against security attacks?
Good point. One question. Proof of work. Proof of work is one of the most, or is the most resilient to attacks, and we do have a use case for that. Bitcoin. We did have attacks on exchanges for Bitcoin, but not on the protocol itself. We never had a hack or a problem with proof of work. But with proof of stake, we do have a set of attacks. Delegated proof of stake, we even have much more attacks because we can buy votes, for example, in the delegated proof of stake. Proof of authority is resilient, but we need to consider this set of authorized or trusted entities. So it's a trade-off between security and trust.
In the chapter, you also refer to 3 interoperability schemes, including one that you use for the web. What are the main logs that explain the lack of standardization in this area, and also the interoperability schemes themselves compatible and interoperable with them?
Good, thanks. So in terms of the interoperability schemes, we do have these 3 that Rémi just mentioned: notary, sidechains, and hash locking. All of them, they are not exclusive. So we could use a combination between hash locking, sidechains, and also relays in a single solution. But of course, they come with some drawbacks. In our case, we have the drawback of private key management in a single solution. But if I would go for a sidechain, it's the level of complexity that is a drawback. I need to maintain all of that sidechain, this blockchain itself. And in terms of the standardization of the interoperability mechanisms, there is not a single, let's say, organization or a single standard for that. These 3 main schemes here, they were proposed by Vitalik Buterin, which is the, let's say, the father of Ethereum, one of the main, let's say, participants there. And he was the first one to really try to put that in text, into categorize that. But if we would have let's say, a standard to build a blockchain, we would need to consider a set of interaction for APIs, for example, or provide some APIs, and then we could provide this interoperability, right? Exchanging data, sending data. I think interoperability is very related to standardization. If we don't have a standard, it's very hard to have interoperability without these solutions.
Thanks, Rémi. You took off by looking at this policy continuum.
Yep.
And when I did see the original paper ages ago, I didn't reread it, but it sort of struck my mind by exactly looking at that point. Aren't those layers not really independent? Because the system view, at least in terms of system definition, includes everything which is below. The business view seems to include applications, but applications belong to the system as well. Why do you believe that your assumption to make those levels, those 5 levels, applicable to the blockchain world does separate nicely between system and network, and where's the application?
Good point. So in our proposed continuum with the blockchain intent refinement, we do have 3 layers that are very closely related together, which is the network view, the device view, and the instance view, because all of them, they are dependent to be blocked. Because we need, as soon as we reach from this policy to this layer to this layer, we already have a blockchain and we need to consider blockchain. So those are very integrated. The other 2, we could start with the system view with policy and then go from that one. And we could also start with a intent and then go from that. So you could start in each part of the continuum in that sense. My proposal. They are not that, as I mentioned, these ones are very correlated. Those ones, they are correlated, but you could separate them if you want.
Okay.
And in the application would be depending on what the application is doing. In that sense. It could start just in the network, or could.
Okay. If I now would start with an intent on the business view level, and would in contrast start with an intent view on the system view level, would they be different?
Yes, because then we were not going to have the intent in the system view level. If I have an intent, I should always start in the business view.
Why?
Because let's say in my continuum, in the system view, I already have a blockchain selection policy. I cannot I cannot define an intent as a policy because it would defeat the, let's say, the naming or the convention. You could see a policy as a very high level intent, but not an intent as a very.
Second, once you, let's put that, you looked at the number of parameters initially, which are examples of those 6 plus whatever dozens of hundreds of alternatives. Which assumption did you have to take to make you feel comfortable or saying, I am able to capture all the intents a non-technical user ever will be able to express? Because if they're on the business viewport, somebody comes along and states whatever, will you have a chance of mapping it all the way down? Always?
Always, I could not say always, but the assumptions that we had to do to select the intent or the parameters in the intent, we saw the policies or the parameters that most of the blockchains provide, so consensus mechanism, the block time, transactions per second, so if they are fast or not, and then we build the intents from that. So it was a bottom-up approach in order to select the intents, and not from selecting, for example, an intent that says, I want a blockchain fit for IoT, right, for Internet of Things. Then in this case, we could, but at the moment we don't support. But we could, if we have this classification of what would be a good blockchain for IoT, for example. We do have one work from Fabian that is using to classify what is a good blockchain for a given use case, for IoT, for supply chain, or for finance, for example. So we do have this. But then, of course, this needs to be integrated.
Good. Okay. So you answered already the question of what methodology did you apply to ensure that you're not running into a dead end, which is indefinitely.
Yeah, correct. So it was a bottom up, and then we had the but the language is quite flexible in that sense. So we could define a new, let's say, profile or a filter, for example, instead of private, public, fast, cheap, or popular, we could use, let's say, fit for IoT, then select the blockchain.
Wonderful. The second part of that assumption world is looking into your related work where you determine that the IETF policy-based management architecture is sort of taken as a, let's say, food for thought, because you look at policies at the end of the day. That architecture by itself is sort of limited and complex at the same time, because you have those policy distribution points, the decision points, the policy enforcement points, exactly that one. What makes you believe that for a large system with those 200 different options, you will find a good basis for determining in a reasonable amount of time directions based on the events?
Okay, so just to clarify, if I would, or if the system would, in a reasonable time, find a blockchain or find a blockchain that satisfies them. Good point. So in this, using policies, we might end up with a blockchain set that is 0, so without any blockchains. But if we do use machine learning, then we could have the blockchain that fits the most the set of requirements. And then, of course, we would have not the best one, but at least a recommendation.
Because deterministic output is nice, but sometimes empty.
Yes, exactly.
And that doesn't.
Yeah. So you could filter out all the blockchains and then end up with.
So you settle that problem.
Yeah.
So I will continue with the next chapter, which is chapter 3. So this is the chapter where we present and analyze the state-of-the-art approaches and related work. We also point out key findings and takeaways that are used as guidelines for your thesis development. So this part really shows that you perfectly mastered the research bit and your capability also to identify adequate enablers from the literature review. I have several questions in that respect, in particular regarding the key findings. The first set of key findings is on representing and refining intents. In particular, we indicate that DFA combined with table lookup proved to be more straightforward and less complex than machine learning based techniques. I was wondering if there are some solutions that could be built by integrating both machine learning based techniques and the based approach.
Good point. So thinking about the related work and those two findings, I think you were referring to this one, the machine learning intent refinement, right? So you could combine, for example, we do have a work that uses a natural language and also uses the ontology and lookup tables in terms of network management. If I'm not mistaken, this is from a good friend of mine, Arthur Jacobs from Works, which they use a chatbot where you can just write any sentence that you want, and it will try to identify the intent out of that, and then use lookup tables to do that. So you could combine this, let's say, machine learning, because then you have try to identify the tokens and from the sentence that is written without a controlled environment, and then use lookup tables to so this.
Regarding the findings on managing user requirements and selecting the most suitable blockchain, so you mentioned that the automation of the blockchain selection process is important about the scalability of the blockchain selection system. Do you think that the complexity comes also from the dynamics of blockchain? Is this something that you looked at, or do you think that the parameters are valid over time or not?
Yes, we did consider that to basically have this finding of why automation is important, right? Because thinking about the currency prices, we see that they vary quite often in 1 week, for example. They can go from $20,000 to $15,000 in the same week, and then go back again. So this is a very dynamic environment. So we did consider that for the algorithms as well. So we always fetch the current prices and then select as well.
And you see also a variation for other performance, so for other properties such as performance ones, or it's
in the performance, we are considering just statics, but we could consider the current block time, for example, because it might vary. For example, Bitcoin, it tries to do it at every 10 minutes, every minute you have a block, but it could go from 9 minutes to 11 minutes. So there is some thresholds there, but we are not considering. We only use 10 minutes, very deterministic. But just to briefly mention about why in the related work automation is important, is because we do have some approaches that are flowchart based. For example, the ones from Burkhard from DTH, where you have, do you need a blockchain? So you need to follow a flowchart in order to select the most suitable blockchain. So it's a very manual process, and you cannot do that with 200 blockchains. So it would be a very large.
You also present in the chapter interoperability work. It appears that in your evaluation you take criteria, so simplified interaction.
Yes.
Can you observe that all the side chain implementations are characterized by no simplified interaction? I was wondering if it's something specific to side chain. How can we address this issue? Technology, or simply because of the lack of user-friendly interfaces?
It's the lack of user-friendly interfaces, one point, and also because as soon as you have a sidechain, you also have a blockchain. So you have solution, or you have let's say addresses that need to consider, blockchain addresses. You have private keys to manage. You have the different block time, different ways of creating and sending a transaction, different data formats. So it's not simplified as well. So, but we can combine the node key with a sidechain, and then you can have this, let's say, more friendly way of interacting.
Makes sense. Thank you.
Thanks, Rémi. Just one issue struck my mind a moment ago when you explained this intent is.
Yes.
Is the intent long enough in terms of living cycle to be usefully, let's say, taking into account for the selection? Or do you see those intents change too quickly?
I think they are indeed, let's say, future-proof, because if I would think about the supply chain scenario, if I would select a blockchain, I would want a secure blockchain or a fast blockchain or a private blockchain, or so the common set of intents that we have right now, they are very basic, but they are generic as well, that they can be applied to different use cases in the near future.
Sure. The crystal ball is not in our hands.
Unfortunately not.
You sort of defined this three-layer architecture of
Yes.
overall, where you have this definition of roles, management, decision, and enforcement. When I take a look at the decision point, which is the major role of the blockchain selection itself, decision has been taken in computer science and application fields since ages. Why is your decision, the mechanism you propose now, very different or completely new, or enthusiastically perfect compared to related work?
Compared to related work, because there is just one related work that is similar to mine, which is the one from I forgot the name of the author. So, but they do have a weighted based selection process, but it's not that automated as we have, because you need to define the weights for the blockchain, right? And in our case, the novelty is on selection algorithms to consider performance or cost. So you could match, let's say, consider meet the SLAs or cost threshold. So you know that you're not going to go over the costs that you specified. So you're going to trigger another policy. Yeah, and also this employment of policy-based management. So defining policies in that case. So not just weights and methods.
Yeah, okay, good checking. The problem with weights or weight-based approaches is that you need to select weights. And we all know that from operating systems, if you have whatever 100 different priority levels between 0 and 99, which priority level do you assign to your process the best possible, independent of how many, let's say, details you have. Did you look into that, trying to determine that your weight, so your weight selection, is not really impacted negatively by such a fine-grained calibration, which doesn't really help at the end?
Yes, because in the, let's say, labels here in the policy-based framework, we're not considering weights, but just what the user is specifying. So, for example, there is no relation of, let's say, private is more relevant to the user, a private blockchain is more relevant to the user than a fast blockchain. So they have the same, all of them have the weight 1, for example, or weight 0.5. All of them, they have the same weight, so they don't have weights in that sense. But we do have one thing that we consider as weights, which is how do we define the popularity of a blockchain, because that's something that we still need weights to do that. So we do have the popularity scores. How do we say that a blockchain is popular or not? And we do have, for example, weights for the number of Twitter followers, the Google monthly searches, and also the papers in IEEE export as an example. And they have different weights. They are assigned arbitrarily in that case. So we do have this problem that you mentioned, Professor Burkhard, but we can adjust this at any time, and the user is free to choose.
Okay. If I'm now a non-technical user,
Yes.
do I understand that formula?
It depends on your background. Yes, I would say no. No, but
Okay.
I think you can understand they are not that that difficult. But this is something that it's transparent for the user. We just calculate that, and then we provide a set of popular and non-popular blockchain, or highly popular blockchains, or low popular blockchains. So, for example, Bitcoin is highly popular, Ethereum is highly popular, Monet, let's say, Cardano is medium.
Why don't you just take the stock exchange out?
Yes, we thought about that, but we also wanted to consider a more academic approach than also we considered in papers.
That's fine.
That's a good point. Yeah.
Is crucial,
Yes.
let's say, impact factor.
And I would say they follow this. If you would go to CoinMarketCap, you would see these blockchains as well there in terms of stock value.
Most of them live this is quite high.
Yes.
highly ranked
Yes.
in that
Yeah.
First 2 pages. Exactly. The first page.
Yeah.
Okay. The last question before I hand it back over to Rémi is on the Bifrost side, because we looked a bit, of course, on the Clavios part.
Yep.
And here on the implementation, which type of, let's say, key assumptions did you have to take to make the implementation as efficient as possible?
Do you mean in terms of performance or
usability? Because there are multiple dimensions to have an implementation.
Good.
Which of those dimensions did you take into account?
So one let's say assumption that we had to make, or we did make in order to make it more straightforward for this to use, is removing the private key management of the user side, which in turn has this trust issue that we need to consider Bifrost server. But for example, if you see the store function, right, how to store a piece of text in a blockchain, the user doesn't need to specify the private key for transaction. So yeah, it's just store, let's say, each defense in Bitcoin, and then that's it. The data will be stored there forever.
Using now the sort of key exchange or the key management is I think, a crucial element, and you argued briefly why. Will all the blockchains support your decisions taken?
Yes, because when we have one address for different blockchains, so one address for each blockchain, and then we just need to create a new address we want to support, and then so even we do have, for example, a adapter that stores in Postgres, which we don't have a private key, but we can provide that.
And address management for the user is again transparent in the sense that he or she is not really involved in maintaining all those ones, knowing this is for
exactly. Yeah, exactly. At the moment, the way Bifrost is implemented, it's that we have one address for different users, but we could have it supports to have one address for one user, for example. It's just a matter of engineering the database to fit that. But then the changes are minimal.
Okay, so it's ease of use to a certain extent.
Yes.
To that. And in terms of implementation performance, do you have some sort of guidelines when I need to provide a new interface for a new blockchain which appears tomorrow? Is that easily done by just checking on the parameters and the intent level, or do I have to understand something besides that?
For Bifrost, you do have a guideline which goes out a little bit in the standardization as well, because all of the adapters, they are implemented in a way that if I want to implement a new adapter for a new blockchain that comes up today, I just need to provide these 3 functions in the adapter: create transaction, sign transaction, and send raw transaction. And then the rest will be, let's say, automatically configured. So it's very agnostic to the blockchain world.
Thank you. So I will pursue this chapter 4. So chapter 4 describes the core contribution of your based environment. The different contribution are essentially described, formalized, technically with the justification of the design choices, and also complemented by several dedicated implementation prototypes. I have a first question that is a bit related to the question that you had on weights. So the solution is based on an intent refinement continuum.
Yep.
How do you make sure that there is also a continuous verification of intent? And in particular, to what extent are the refinement steps verifiable and explainable for users?
Good point. So as I mentioned in one of the future works, or in future work, our areas is to guarantee that the intent is being refined and fulfilled during this whole life cycle, during the intent continuum. That is something that we are not considering, we're just considering a straightforward way. But thinking about, for example, the intent, as we have intent based on a state machine, we can explain to the user and show to the user where the problem was. For example, if I have, just going here, if I have an intent that says, for in-client access in the day, select the fastest blockchain, public and stable blockchain, except Bitcoin, encryption, and to daily cost switch time. Right? We have this intent, and then we can parse this intent in the state machine, and then we can show, for example, if the user wrote, select the fast blockchain, so a token that doesn't recognize, we can in this state here provide a error and then show there's an error in this part, please fix. So it's in this sense explainable in that sense. And also the user we provide a front end for the user to see the blockchains that the policies that are available for the user. So each one of these policies here, they were created based on an intent, so the user can see which is the policy that was
The automated selection of blockchains is based on those parameters that you mentioned here. I was wondering if it would make sense to actually integrate the environment with the monitoring architecture to get actually measurements that are done directly by the architecture.
Yes, it would make totally sense, and it would be one step further to really complete the whole life cycle, which is something that is very important, but just limited the scope a little bit of the work.
And you see that the Bitcoin API, so you presented it, it's very convenient, I think, for developing new adapters. It's very convenient and easy to implement way. I don't think it makes sense to extend the API to some monitoring functionality.
Sure, it will make totally sense. That's a very good point, because we need to have the nodes in Bifrost. So why not monitor as well these nodes in the blockchain itself? So yes, that we could.
Thanks. And you presented the example on slide 12 on the CNL to pseudocode example. Transforming activity, and you decided to have the CNL representation being improved in Python, if I'm not mistaken.
Yeah.
Was it a good choice?
Yes, it was a good choice, because Python allows you to basically create, any solution, or let's say programming language that provides this way of structuring a state machine using classes and so on. So any class, any object-oriented language could solve that. And the good thing about Python is that you can prototype very fast some of them. And also Python provides some libraries, not that other languages don't provide these libraries for processing natural language, but Python provides. So I think it was a good solution. Good decision.
Yeah. Okay. Thank you. Secondly, IRK2,
IRTK.
Okay, pardon. Remains, of course, in that programming language. Did you suffer any sort of integration problems with the other components when you had to hand over the decisions taken, or was that straightforward?
It was straightforward, because all of the solutions, we made sure that we provide an API for that. So for example, the policy-based bills, we do have, besides the graphical user interface, we do have an API. So other solutions, for example, IRTK could be here and just send a JSON, and then it would work. So all of the solutions, they have this, let's say, API being defined. So they could work together as they are now, or they could work in a modular way just by themselves in a standalone.
Fine with that. Good to see the transaction generator in there, and your argument made earlier that you referred to the sort of key management, key handling issue. Do you have any trust assumptions to be made on the transaction generator at some point in time, depending, of course, a few, let's say, previous assumptions? Is that doable in general, or it's only doable in certain cases? If you could refine that, maybe.
Yes, thanks. So just clarify this transaction generating these labels here. It's a transaction to Bifrost, to the interoperability API here. But the actual blockchain transaction is created in Bifrost. So the trust assumption that we have is we need to trust that the notary is indeed sending the blockchain, the transaction, creating, signing with the private key, and not change the data. But that can be verified by just retrieving the transaction from the blockchain and then seeing if the data is there or not. And then, of course, not trust the notary anymore. So you could. This is the assumption.
Good. So there's a verification possibility.
Yes.
Even for the non-technical user.
Even for the non-technical user, if you would think about a blockchain explorer just by typing a hash or something in that sense. So yes, you could, because the user would just see, for example, would see, of course, a lot of numbers and values, but the user could just see, for example, the data that he or she included here, based on that transaction.
Yeah, that's good. You refer to that because the blockchain explorer is typically not for a non-technical user.
Yes,
but there is some field of
but yes, there is some field that we can verify.
Yeah, that's it. Good.
So I continue with chapter 5, which is a chapter on the evaluation, where we evaluate each layer of the proposed architecture. So the chapter shows a very complex and rigorous evaluation, both quantitatively and qualitatively, and also in the presentation, that was used to validate the feasibility and the performance of the solution. The chapter also includes a section dedicated to a use case.
Yes.
The called chain use case from the medical driver distribution area. We discuss in particular the benefits and drawbacks of applying machine learning techniques. Could you elaborate further about the scenarios and data that have been considered for this experimentation and the benefits of the solution with respect to this use case?
Yes, sure. Just to clarify here, so this was the scenario. It was a scenario about a cold chain. So cold chain sending drugs, temperature sensitive goods, for example, drugs or vaccine. And if we think about the company has some, let's say, specific requirements. So as soon as the drug leaves the company, and then it's, let's say, stored in a box, and then sent to the logging or the transportation, the company doesn't really care which other blockchains are working with that one. So we already are abstracting one layer there. And if the company says, I want a popular blockchain, or let's say a secure blockchain, or in that sense, we're going to select, for example, Eder. But for the logging or the transportation company, we are going to be monitoring the temperature every single, let's say, minute, second, or it depends on the definition. And then it would want, let's say, a cheap blockchain in order to not spend too much sending data. So it could send to, let's say, IOTA or Stellar, the more cheap blockchain. The final destination here doesn't store anything in that sense, but can audit the data, the transaction or what happened, just by interacting with our system, just retrieving information and without knowing to which blockchain it was stored. So abstracting all of those details from the final destination, also for the government that wants to.
The qualitative evaluation includes also a deployment security assessment, in particular the Bifrost prototype, which is critical part because it maintains the hypotheses and credentials to the database. I was wondering if there are specific attacks related to the intent-based management part.
Ah, good, good. So we could, yes, there's always, there's no 100% secure system. So of course there is. So you could, let's say, personificate as some user, define an intent that says, I don't care about the price of the blockchain, and then make the user pay more than he or she wanted. Right? So you could, this personification of users. For the policies, you could change, for example, some parameters, and then let's say impactful selection of all other persons that are using the system, for example. So yes, there is some attacks changing.
Makes sense. Because I mean, if you look at managers, very free. You want all functionalities, you get it for free.
Yeah.
What do you do with those requirements? I mean,
yeah.
I mean, typical manager says everything is nice, and I want it for free. So how do you deal with the situation that the intents may be unreasonable?
Ah, unreasonable. Good. Intents being unreasonable, we are going to just try to select a policy still. We're not considering if they are not unreasonable. But for the blockchain selection, the user in that sense is going to, let's say, select the threshold of costs that he or she wants to reach. So let's say 10 francs, and that's okay. And then we can just, let's say, if we are going to have the system as a product, we can just charge them as much as we spent for that user. Right? So,
I mean, if I were a user, I would charge the system, put in anything. I want everything, get it for free. I want most, I get it for free. I want most, I get it.
But still, the user can specify a lot of intents. But remember that the transaction is going to be sent to a blockchain, and that incurs costs, and then we can charge the user with that. For the storing of data, we can charge, not for including intents or sending intents. But interacting with a blockchain, for example, Bitcoin, we can charge how much we spent on that transaction, the fee, and so we could send them a bill at the end of the month saying you spent this and this amount in these transactions. So this, let's say, business support system, it's provided within Bifrost and not on the.
But couldn't you indicate what is reasonable and what is not reasonable?
That it's very, let's say, dependent on the user, because something might be reasonable. For me, it might be reasonable to spend 1 million in Bitcoin.
No, not reasonable for the user, but reasonable in type of expectancy.
Okay.
Get everything for free.
Sorry. Yeah, we could, but then we will need to have this feedback loop as well.
And you don't have that.
No, that's something that it's out of scope for this. But for the future work,
that's what I was
perfectly doable. Yes. Yes.
So the evaluation part is quite complete. I was wondering, more general question, what are the additional experimentation that you like to do in the future?
Mm-hmm. Yeah, but good. So I think, or I would do on Bifrost, I would keep track or evaluate how can we keep track of this monitoring and keep track of the let's say the solution, how much time each transaction was created, how much time it took, and then maybe have a let's say, yeah, something that we could do an average and then provide more detailed information out of that. For the intent, I would also like to do more questionnaires, and more like a system usability. Yeah, I will do that with a more questionnaire. So with more questionnaire, more people, because 19, we sent to 100 users, 19 answered, So I would try to increase that, and also with more, let's say, yeah, usability, system usability survey, system usability survey. Yes. I think that would be something that would increase the overall evaluation.
One of the standard questions is, when do you look at evaluations? Is your system scalable? Is it?
Yes, it is.
In which dimension?
In which dimension? For Bifrost, the overhead was not that that large, so we could scale to more users. That would be perfectly fine. For Plebos, for the selection, we do have a complexity of selecting a linear complexity. So that depends on that scalable means it's quite hard to say, but it's better than O of n squared. So not the perfect log of n or O of 1. And for the intent, I would say it's scalable as well, because we could also increase, let's say, the amount of intents that we support, or the number of parameters. And so each one of them, it's scalable in its own dimension. Most of them are related to the machine and not the, let's say, the method.
You already showed the application scenario. Because the question I would have asked is there a proof of concept besides all those nice elements of implementation? And if you take that model case at hand, would you say that Modem is happy about such steps you have developed over time and used it in their, let's say, setting?
Okay, good point. So we can ask Thomas. I would say yes. I would say yes, because the technical and the implementation side is there for if they want to use. But I think one point that during some discussions with Sasha, one of the technical officers there, that we had, was that the clients, they were a little bit afraid of going to a different blockchain. So they are using Ethereum at the start of the smart contract. And then, for example, we could just use Stellar or IOTA, but then the users are more reluctant, and they are much more, they tend to go to a private blockchain because the costs as well. So because it's basically a matter of costs. Ethereum now has their fees were quite high in some previous years. And then if you go for Hyperledger, you don't have costs, just the cost of running the node, like the hardware costs. Yeah, so that was, Mod was happy. But the clients, I think they were the main, yeah.
And if you refer to costs, is that a storage concern, that there were too many data to be stored, or was it a too frequent activity every minute, every whatever type of interaction they did have at hand?
The way, if I'm not mistaken, Modem set up the transportation to send data was that you record once, and then you keep recording in the logger. So in that small device here, so you keep recording that in the logger. As soon as you reach the final destination, you would read the QR code, send to the smart contract. So, and also it's just a hash, so it's not about the costs of the sending data that often, but the costs incurred in sending the fees and so. Yeah.
Thanks.
So I continue with the last chapter, which concludes the manuscript and points out promising research perspectives, in particular in the future works you mentioned development of a decentralized version instead of considering a notary scheme. How will we implement it, and what changes does this require on the architecture?
Good. So Bifrost, I think that's the main core decentralization that we could do. So Bifrost at the moment, we do have these credentials and the transactions stored in a single database, in a single server, but we could decentralize Bifrost to the user. But of course, that introduced some concerns of management. So how do we handle the credentials, and also the blockchain nodes? We need to have that. So Bifrost is able to be deployed in a server, a centralized server, or within the company premises. That's totally fine, because it will be the same solution or same architecture in that case. But then they need to consider the blockchain nodes. They need to consider or have the technical expertise to set up the nodes, to manage the keys and so on. So introduce more management complexities. Yes. And with playbills, you could also have that in your on-site. Yeah, so that sense to be decentralized. This selection could be performed in a smart contract, running, for example, in Ethereum. But then, of course, the simpler costs to interact with that smart. That would be a total decentralized selection process, but very expensive. I would say very expensive now, given the costs. But if there is a blockchain that provides a more, let's say, cost-efficient solution.
You mentioned also the auto-configuration of selection algorithms using artificial intelligence. Could you elaborate about this?
Yes. So we did have one research already being started to be conducted using machine learning, using different algorithms, decision trees, random forests, support vector machines, naive Bayes, to select the most suitable blockchain for that case. So using, let's say, machine learning, not artificial, area of artificial language to select a blockchain. We did have some promising results with decision trees, random forest, and support vector machines. But naive Bayes, we did have a low accuracy because of its algorithm.
And how do you explain this is lower score?
For naive Bayes, it's because it's the high amount of correlation, or the low correlation with the naive Bayes, if I'm not mistaken. But for example, for decision trees, which is a very explainable machine learning algorithm, you can explain how you reach the decision. It had a good performance and a very low performance. But it was good because it also gave us some nice insights. For example, as I mentioned here, the popularity is highly correlated to the type. So public blockchains, they are more popular than private blockchains, but that's of course the point of the formula that we consider: Google searches, Twitters, and academic papers.
So the selection process ends at selecting the most adequate blockchain to implement transactions. Would it make sense to introduce some redundancy for the storage of transactions with multiple blockchains at the same time? Would it make sense? Are there benefits or drawbacks?
Yes, good point. We already provide this redundancy in the IRTK. You can specify this modifier, as we call it, redundancy. So what this modifier does is it just sets a flag to the policy saying, I'm going to store in the blockchain that's selected, plus in a database that we have, like a central database, just for redundancy. If something happens with the blockchain, you have on the database. But I would say it's more likely that something happens with the database than with the blockchain. But yes, we do provide this redundancy. And also we have this splitting of transactions. This means that we're going to select more than one blockchain and then sending into a round robin scheme. For example, if I have 3 blockchains, sending data to this first one, then to this one, then to this one, just to like split the transaction into multiple blockchains. But not.
And for the redundancy part, you can also target several blockchains, not only database, but blockchain.
For redundancy, no, we didn't consider that, just a database. But that would be just a matter of engineering to send into a different database, to the blockchain, for example.
You think it would make sense? Or
I think it would make sense, but as I mentioned, also it would incur some costs, because if I would, I think what would make sense is to have a public blockchain being selected and a redundant private blockchain. Then you don't have that many costs, but you do have this redundancy. So it could be done.
Thank you.
Thanks. My last question is only looking into the future. If you take your approach and now would like to handle smart contracts,
Mhm.
do you need to recompile the system with a different parameter and you're done, or do you have to think about it more?
Good point. So smart contracts, depending on the blockchain. So for Bitcoin, very limited smart contracts, only scripting language. It will be a little bit hard because we're not actually storing data indirectly. For Ethereum, for example, it wouldn't be that much of an effort. It will be an effort, of course, but not in terms of rewriting the whole Bifrost, because we are already using the same field, which is the data field, to send data. So it would be just a matter of sending the call data to the smart contract, and then it would. So it's not. It's of course more work, but yeah, not a total rework system.
So it's more engineering thoughts to make it work.
Exactly, yeah. But the design, the architecture, everything is supports that.
Sounds good. Recompiling with
Like,
I have one short question. It's very, very naive. To take slide 5.
5.
You have to know that I have an IS background. And I don't understand the dichotomy between abstract and technical. For me, the dichotomy is abstract and concrete and business and technical. But I don't get why business is more abstract than technical. Normally, I would say computer science is more abstract than business. So can you tell me what drove that?
yes, so good. This clarification, I think, is pretty good to do. So in the business field, we have very abstract requirements.
Why is it abstract?
Because
It's very concrete. It's very lively.
yeah, but okay, so it's very abstract, concrete, but also subjective, let's say. So it's a very abstract, not technical. That's it. So in this case here, I'm using abstract as a synonym for non-technical.
Okay, then it's okay. Then we don't
yes.
need to discuss it. If it's non-technical, technical,
Yes.
then I got it.
Yes, it's
Just
just
abstract, technical is
Yes.
the dichotomy
Because-
doesn't make sense to me.
yes. Okay, good point.
Okay, non-technical,
Yes,
does.
but it's just a synonym for non-technical.
Okay, then just that. Any questions from the group? Anybody? Yes, of course.
Yes.
Now that's the killer question.
I was wondering why is Stellar so slow?
Stellar. So in the evaluations, security transaction creation. Yeah. Here.
It's by far the slowest one.
Yes. That was because we were using a remote node, not a local node. For that.
The other ones are also remote.
Yes.
And there's a huge difference between 500 milliseconds
Yes.
and 4 seconds.
But that I cannot say because that's just a remote node. So that could be the implementation of the server or some like where the server is located. So it might go to a longer path. It's just in terms of network latency for that. So this node might be, for example, in Brazil. Then we're just send it to Brazil. Then it would take 5 minutes.
Any more questions? Sorry, I didn't want to disappoint you. Any other questions? Anybody else? Okay, then I have to unfortunately take away outside a little bit more. I guess there will